remembered before you told me. All right, so today's lesson should be kind of faster, and it should give us a little bit of time to get a head start on homework or catch up on homework if we need to. I already have tomorrow's homework back and ready to go, so if you guys are all caught up and somehow you already have today's done, which I doubt it because I didn't have today's available for you before today's, but at the end of class today, hopefully we'll have a little bit of time for you guys to bank some time for the week, because then we're moving quickly and our Chapter 7 Mastery is this Friday. So, hear me when I say Chapter 7 Mastery is Friday. If for some reason they take a class day away from me, which I don't think is going to happen, but science fair things might get goofy, that might get adjusted, but I doubt it. Any other general questions aside from what's that, which is a bulldozer breaking up concrete? Or it's, a robot. It's a robot trying to, I don't even know. Alright, so who remembers Newton's revenge and can talk about it? By the way, if you didn't get 722 or 732, sorry, raise your hand, I'll bring you one. If you didn't get today's worksheet, raise your hand, I'll bring you one. Who remembers Newton's revenge? Let's talk about it. Alex, do you remember Newton's revenge?
Yeah. So, essentially, it's this roller coaster, and there's that one part, there's this tunnel, and they want to make sure, your fingers don't get chopped off.
You got this. 732, today's worksheet. I'm just asking if you need this. Oh my gosh, come with me to math class. Join me. Nothing's due today. Are you listening to what I'm I was asking you if you needed today's worksheet that is today's homework. Okay. Are you ready to start class? Because I'm worried that you're somewhere over here and we're down here. Okay. Sorry, Newton's revenge was, Alex.
Alright, so it's this roller coaster that they're building, and it has this tunnel at one part, and they want to make sure your fingers don't get chopped off.
Or your hands, or your forearms, or any part of your body is probably a bad idea to chop it off. It's just messy paperwork, the whole thing. So go to 732 in your ebook, and you will find in problem 97, not only is there the table full of data, but more conveniently, down here, 797 student e-tool, click it. All of that data is built for you in Desmos. So you have an XY table here shown to you with all of your data points. You could add data points if you wanted to, but don't, because then you'd just be making things up. Here is your task at hand. By the way, these arrows drop away the sidebar if you want. Your task is to determine, I'm going to give you probably a good 10 or 15 minutes to do this. So if you get done with it, just work on your homework. Okay? Please don't act like an elementary child who does not know what to do with time that you haven't been told, do this thing. Right? Use your fragments of time. Start your homework if you get done. But here's your task. Everyone hands up. On your head or something. I don't care what you do, but if you need to go on your head, on your head. Your team, might be just you, I don't care. Your team needs to determine a y equals mx plus b form equation for this data set. So before you can do that, you need to determine what the line of best fit would be. To do that, you have this line that you can move. These points are your lattice points that determine where that line is. So both of these points can be moved in, out, whatever. You can zoom in and out on your graph by using either if you can pinch on the Chromebook or click up here, zoom in, whatever. Here is your zoom in, zoom out. But you guys know what we're talking about with y equals mx plus b, right? M is your slope value, that association, kind of that slope. B is that y-intercept value. And then, keep your hands off your Chromebooks. And then, if, who remembers Yao Ming? Anybody? Or am I just that old? Who's Yao Ming, Xander?
He's this basketball player from China.
Is he just some basketball player?
No, he's 7 feet tall.
Like 7 feet tall Josh.
Isn't he like 7'6"?
He is 7 feet 6 inches tall. Guys, take me. Hold on, take me, add 4 inches from above that. Then add a foot. And that's Yao Ming. So what we're going to do is try to then figure out, can Yao Ming ride Newton's Revenge? He is 228.6 centimeters tall. Now, us Americans would say he's 7'6", but the rest of the world would say 228. Like, you'd go into the doctor's office, they'd say, oh, what's your height? And you'd say 228.6 if you wanted to. So, I'm giving you until the big hand's on the 6. So, 230. Serena, tell everyone what you're doing with the next 15 minutes. Make sure that you weigh in the back.
We're going to be making the line of best fit and then dividing the y mx plus b force.
And then?
And then we're going to be doing homework and working on stuff once we finish.
Oh, there's one more objective after you find your y equals mx plus b. Who do you have to see if they can ride the roller coaster?
Oh, it's the y ming person.
Yao Ming, who's 7 feet 6 inches tall, or 228 centimeters. Are we all clear, Henry?
So what scale would you recommend making your graph?
That's our. You don't even have to do this on your paper. I mean, you could, but we're using the computer, so the scale changes as I zoom in or zoom out.
Oh, okay.
Yeah, as you zoom in, it gives you more boxes and it changes your scale for you. So as you zoom into the x-axis, your scale goes to like infinity.
Well, it's
Well, that's so
not changing the scale. It's just showing
Yeah,
the
it
scale
is.
of boxes.
Well, that's changing the scale.
Well,
Right now, the scale is 1 box is 1/5.
yeah, but then when it's still well, yeah, but then they're splitting the boxes.
And that changes the value of 1 box. I know what you're saying, but it does change the scale. Like, I'm just not letting you get away with that because it does change the scale. The scale is what is 1 box worth. You know what I mean? Like the scale of the graph, quote unquote. Because like when we zoom way out, 1 box is worth 10. Right? Here, 1 box is worth 10. That's our scale of the axis. All right, so the big hands on the 6.
Wait, what are we doing?
Just this, those objective activities. As your team has an equation come up, send one person up, write your equation right here, and then your answer to can he ride.
He can ride, but the question is, can he ride without getting chopped off?
Can you come out alive?
Can he come out alive? You mean not amputated?
Pen is there on the hole puncher.
Can we just do that as we look at it?
As you figure out what you think your line of best fit is. I was gonna say, you're part of that group. It's probably pretty hard to see that number right now. Remember, you can't really add points because,
Well, no, I can add his points. Right?
I mean, yeah, but do you know the y value? What was x and what was y here? Do we remember that? Henry? X was height and y was reach. Right? X was height and y was reach. Hey, are you on task? I'm just asking because you're.
Mr. Hudson, can we round? Negative 20. Well, what x plus negative 20?
I mean, you can round to like the tenths.
Because we have a
said. That doesn't sound like it's on task. If you go back to the ebook, I think it shows you a picture. I believe you go back to the ebook, it shows you a picture. 200 centimeters for the tube. So the reach depends on height. The reach depends on height. I mean, you can keep looking forward if you want to. You can start working on your homework. Yep. Yeah. Once you have your equation, write it on the board. Once your team has your equation, write it on the board. They will not all be identical. Right here. Or you can do that. Dude.
Is that big?
Look at how sloppy that is.
I thought this was supposed to erase. Yeah, I'm a big guy.
So, big eraser. Big eraser.
Oh, yeah, okay. I'm gonna
Then, scroll down. Then, use a pen. Here, you can still write in purple.
Okay.
Do that.
Okay.
But, like, y equal, like, don't just slop stuff up there. Make it look nice. Guys, if you're coming up to write on the board, you are not slopping whatever crap you might be able to read, maybe, hopefully, in a minute, but by tomorrow you'll forget what it says. No, you are writing something nice so that your classmates can read it and understand it. So wait, you don't have a B? No B value?
No.
No B value, okay.
Oh, this is weird to write. I don't want this. Because. Oh, that looks horrible. I don't know how to write on these.
So that's really bright. Yes.
Brown to the 10.
Oh yeah. Oh yeah, round it. So we have a B value from Katie Ann's.
Oh, wait. I didn't write the other.
Hey.
By the way, how tall is this kernel?
200 centimeters. Yeah, once we start working in metric and do centimeters. Tunnel is 200 centimeters. So guys, remember, bring your focus back for just a second. If I am Yao Ming, which of course I'm not, and he makes tons of money, and he's way taller than me, he's 228 to here. So he, when he does this, is way taller than 228. That's not what we're thinking of. We're thinking of when he is seated, so essentially subtract part of his legs, and depending on your body like makeup, your legs might be longer than your upper body. We could do the math. So what really is the disbursement of leg versus upper body, like torso and everything else. But he's gonna sit down and then reach up. Slash, we would also kind of maybe need to ask, is he even safe to ride it seated? And then can he reach?
Yeah,
We've
because
got a few yeses.
his center of gravity would just be like.
So we've got, if we decimal these values, we've got 0.75 as our slope, 0.8356 is about 0.83, 0.87. Who else has a slope value to throw out for us? Simon?
Is there anyone who's a no?
Did anyone think he cannot ride? Let's look at the Desmos of it. He's 228. We talked about that. He is 228. Oh, 200. I've said that many times today. So,
How tall is the seat?
did anyone place your lattice points right on points, or did we just kind of try to average stuff? Who? Actually, let's random card.
That's been a long time.
Alex, can you remind me what we're essentially trying to do when we're placing this line of best fit?
You would have about the same amount on the top and bottom.
Yeah, we want to have approximately the same amount of points above and below. So if I lay this out, and I don't have to be right on one of those points, but if I lay that kind of like this, I have a lot above. That's pretty close. All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I've pretty much balanced these out. Now, are all my points really close to the line? Yeah, it's like, if I zoom out, they look closer, but still, there's some spread here, right? This is kind of high above the line. These are a little bit below the line. And then to check for a y-intercept, we're going to come over here. According to what I have like a y-intercept of like 20. But how do we figure out our slope? Bear, since you're standing here, going to pick on you. How would I figure out my slope up here?
Well, I just found the x-intercept and the y-intercept, and I used that to figure out
The x-intercept and the y-intercept.
Oh,
There's no x-intercept here.
Well, I mean, it'd be negative, but still.
It would be negative. You're doing too much work. Because you don't want to make this part of the graph. If you were graphing this on your own, on your paper, you don't want to make this graph.
Move to the next one then and see how much it grows.
What do you mean move to the next one?
Well, zoom just a little bit more. And
Like all the way to an x of 1?
sure.
You're still doing too much work. This is why I'm glad that we're talking about this. Bear, I love when I find something you don't know yet, because it actually makes me feel like I have a job. Simon?
So, I just want to mention, what I did was I put the beginning point on 0, 0, since if you were 0 inches tall, you would have a reach of 0 inches.
But does that mean, I agree, but does that mean reach and height are always proportional?
Well, no, because it's a line of best fit.
No, so that's the issue. I agree with you that 0, 0 like scientifically would exist, but that messes with my line of best fit, right? Because then, like, maybe I can do like that or something, but I don't know that. Yeah, that might. I mean, that kind of matches. This is kind of far away. Guys, here's what I'm trying to get you to remember about slope. If you know what this point is, and if you know what this point is, change in y, bear you with me, change in y over change in x. So what we're doing is we're saying from 117 to 137. So like 20, right? Like 20 is my change in y. My change in x from 155 to 178
22.
is like, yeah, it's like 22, 23. So 20 over 23 becomes my slope. That's it. Use lattice points from your line of best fit. Now, what you said, Bear, wasn't wrong. Bear was saying use your x and y intercepts. If we come out here and we find a sloped triangle using x and y intercepts, that will work, right? Those 2 points at x and y intercept, that's also a sloped triangle. It's the same line. But I'm telling Barry's working too hard because we don't even need this part of the graph. What we have is this part of the graph. We could just use 2 points in that section. By the way, the old smartboards couldn't do this, and this is cool. I like that a lot. Avi?
One thing I did was just use the x, or not the x, the y intercept as one of the points in the triangle.
You can, yeah.
And it just made it a lot easier.
So what Avi is saying is if we have a y-intercept, if my line is more like this, maybe, then he used this point with an x of 0 and then some other point on the line. And that's just as easy. Yeah?
To even make it easier, I went to 100, the whole number, and then went across.
Yeah, and like just found another point like here. Yeah.
I found, okay wait, I put my line up.
So I'm going to go over here because we got hands up. Henry?
We can just, if we have a line of best fit, we can just go up to the board and write it, correct?
Yeah, but now we're going to keep moving on. Like, we could keep doing that, but I'm going to try to give you guys some homework time. So, all of your slopes that got written up here were pretty close. A little less than 1, right? So your slope should be a little less than 1. But here's what I really care about. How do we then use this data? Let's say somebody, we'll go random card again. So Henry, what was, I said random card, but Henry, what was your equation? Go ahead and give me what you
My
found.
equation was x times 5/3 minus 143.2 equals my line of best fit.
5x minus 140, 5/3 x minus what?
143.2 equals y.
So let's say this is the line of best fit Henry's using. You've got your line of best fit, right? We will talk later about judging how good or whatever the line of best fit is. How do we then use Yao Ming in this? Xander, what do you think? Now, I did use random cards. How do we use Yao Ming and Henry's line of best fit to determine if Yao can ride the roller coaster? Well, how do we, what is that, what's that 228 become? Is that our x or our y? It's the x, right? Because we said that our height values are our x values, so we just substitute. It's a nice math word that you got to get used to because it will make your life easier. If you plug that into your equation, then you can test it. Will he be able to ride safely? Avi? So Henry's slope's a little high. He made his line steeper, but his y-intercept is way low. So Henry's line probably looks more like something like this, going through the data in a bit more steep of a line.
Yeah, that looks about right.
But does it still fit the data pretty well? Yeah. So actually what we're seeing here is exactly what I was set out to teach today. When, it's almost like it was on purpose. When we have data clustered together, we can kind of talk about the cluster using different vocabulary words, and we start to talk about the strength of the cluster. I don't know what I mean. Anyone read your notes yet? Like your homework paper for today and look at what we're talking about? Hazel?
Like how strong the association is, like how clustered the points are.
Yeah, you want to give me more? You want me to move on?
That's all.
Audrey?
Oh, I was gonna say the same thing, but you can have a strong one, which means like all the points are literally on the line, or a moderate one, which just means some of the points are on the line, but like most of them are kind of spread
Yeah.
But then weak is like they're all over the place.
Look here. On your 732, look here.
Yeah.
This is like I said, guys, this year different than last year. Like my students in previous years didn't have this stuff because I was just saying do your homework on graph paper. The things I put in there as examples from class, that's important stuff. This is what kids were struggling to understand last year. So put your eyes on that right now. The strength of association comes from how close the points are to the line of best fit, or whatever line we're talking about. So this section right here is a great reference back for you that this is kind of the situation we're dealing with a moderate association. Our points are close, but they're not like really definitively showing me where my line should be. That's how Henry's line was really steep. And like, let's say we ignore, hang on just a second. If we ignore this point, that point, that point, that point, and this point, ignore these 5 points. Aren't these almost like a perfectly straight line? Yeah, like, so this is not a point, remember? Like, that is the lattice. Like, okay, we could ignore that one. If we ignore that one, man, these are like almost all right there together.
Ignore the other one too.
Mr. Kabila, you guys talk about line of best fit in science ever?
We're talking about it, just started talking about it. They made a mass and volume graph, and they added a line of best fit to their graph.
So Math 8 kids should at least know what you're talking about.
Yes. I mentioned in my video about their the R squared just briefly.
Now, I don't talk the fancy names.
Yeah.
We just talk about strength of association.
Strength, yeah.
What's R squared?
The strength of association.
Thank you for asking. I was hoping somebody would say, like, wait, what's R squared? R squared is the fancy calculated strength of your association. So, have they watched the video yet?
I don't know. Did anybody watch the video on how to make the graph?
Or do you have
For the
Patrick, can you tell us any more about R squared?
I watched it muted because.
Oh,
Wow.
that's a really good defense.
I also put a video right below that about finding the slope of that line too.
So here's why Henry's slope was so different than the slope a lot of us had. This association's only moderate. There can be a huge discrepancy in the slope because there can be a huge discrepancy in what line we draw and say is quote unquote best fitting. If I try to fit this point, that's going to pull the end of my line down. But if I ignore that point and say, well, forget about you, you just don't match what you should match, what is this point now going to be called? An outlier. So we give you that as well. Now, the other thing that I wanted to show you, draw the line of best fit for this data real quick. Draw the line of best fit for out here where there is the outlier. Ignore the outlier, but draw the line of best fit.
Do we need
Careful.
freehand or
Yeah, just freehand it. It's not a parabola.
It's exponential.
It is exponential. If we try to draw a line of best fit, it is a curve, right? No. Not all lines of best fit are straight.
Because not all lines are straight.
Because not all relationships are linear. Right? So like, you're right, but well, all lines are straight. Otherwise they're curves. But, so this quote-unquote line of best fit is really a curve of best fit, which then we're not using, hey, hold on, stay with me for like 10 more seconds, then I'll like let us do homework. Here, hands off keyboards or whatever. Here we would not be using like a point here and a point there to do delta y, delta x. Stay with me for a second. We'd be looking at a multiplying factor for what happens to go from one to the next, to the next, to the next. And the same can happen, and this is probably where you'll talk about it in science, with exponential decay is a curve that comes down as something like disappears. Like if you put something outside that's going to like decay and like disintegrate, like there will be a curve of exponential decay. This is exponential growth, like some bacteria that's taking over, like pandemic or something like that, like an uncontrolled pandemic. Yes.
Wouldn't you use there are two things. Wouldn't you use like an exponent like for the equation?
Potentially.
Yeah.
So the two types of equations you might see here are, well, there's many, but there's a times x to the something, or a times b to the x. And this blue line would actually probably be a times b to the x. There's some a value, some b value, and the x is actually your exponent.
Okay, and also.
You don't have to write this stuff down.
Well then. So, yeah.
So yeah.
No.
No.
I was gonna say that not in like the real life situations, you wanna actually normally you wouldn't have linear. Like,
Can you think of a situation where?
well, a lot of situations like the ecosystem, because right now, like there's a huge uprising in temperature. Well, yeah.
Polar bears will have to come to
So,
Ohio.
It's like a hockey stick graph, kind of.
Look at the value of a car. Camry, Crown Vic, Accord, Malibu, Escalade, Caravan. I don't know what that is. Has anyone ever heard about when you drive a car off the lot, you like lose $1,000, $5,000? There's like all sorts of weird expressions. But if we're talking real life situations, exactly like Alina is trying to get to, the most common exponential decay situation is your car. When it's brand new, no users, no miles, no owners, it's worth the most it will ever be worth. And the biggest hit to the value, the biggest drop, is when you buy it and drive it a mile. As soon as it's used, you lose a ton of money. But then it's used, and it slows down.
Could I please have Skylar Stumball to the remote office? Skylar Stumball, please come to the remote office. Also, at the afternoon break today, if I have any current 8th graders that will be going to Thomas Worthington High School that have an interest in soccer, please stop by the remote office. Thank you.
Logan?
Two things that might be like little bumps in the road for this. First things first,
Bumps in the road.
what if a celebrity drove in that car one time or something?
Yeah, that'd be an outlier. Move
And
on.
also, another thing is, after a while, the value would start going up. Because vintage.
Not for most vehicles. Yeah, that is very, 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 very rare that a vehicle gains value by getting older. And that would only be if it was well maintained.
If it was 1,000 years later and we found
No.
I don't know.
My Honda Civic, my 94 Honda Civic that I drove in high school is never going to gain value. There are thousands of them still on the road, and plenty, no. Those are like rare vehicles that disappeared that somebody maintained really well, didn't drive, like it sat in a garage, grandma owned it, she never drove it, yeah, that happens, but it's really, really rare. So those bumps in the road are like outlier situations. That makes sense? So, again, I will say, you can be working on your homework right now. I will always answer your questions about math, but you can work on your homework right now. Avi?
On 7.102, are we supposed to draw a line of best fit? At the start.
I can't find the screen we were on.
What was the thing that you just looked up?
Value of a car graph.
Value of a car graph.
You don't have to draw the line of best fit. The biggest thing here is describing the association. So to describe the association, you are talking about positive or negative, strong, moderate, or weak. So hey, good question from Avi. When any time you're asked to describe the association, it's positive or negative, and, or none, I guess there could be none, and strong, moderate, or weak. There's two things you're saying. Direction, like positive, negative, and strong, moderate, weak. Weak, really big spread. Moderate, kind of close. Strong, pretty much on. Yes?
But on B, it asks you to draw the line of best fit.
No? Well, okay. Does your y-intercept make sense?
No,
So
it
sure.
also says copy the scatter plot and draw.
Oh, because I typed it in there, didn't I? Did I? Avi, why are you asking me questions that I already typed the answer to?
Sorry.
Henry?
Sorry.
because I modified this
So-
homework.
How about we Google a list of cars that are worth the most money, that are
Sure.
old?
You can on your own time, not in my class. No, you guys can Google anything you want. I'm just saying right now I'm giving you time to do homework because often y'all complain that I give homework all the time. We have a test this week and homeworks are due, so do your work.
But you technically still
I love how it copies that and then that. Probably that I have not updated anything from over the weekend. So if I do, these were not mine. Oh, these are. Well, somebody run these to Mr. Padilla.
Yeah, I can.
Yeah, Liam, you're right here. So I will be updating this evening. I'm supposed to go rock climbing, but I might cancel on my buddy because I got work to do. Nice. Well, thank you very much. That I will be updated this evening as well. Thanks, dude. Hey guys, I'm gonna make the shameless plug now because you are you are probably one of the highest probability groups that this would land for. This weekend, on Saturday, we have the opportunity to show all of them other middle schools that we're the best in math.
Shameless plug.
Right? So, Math Counts is a no risk. This Saturday's competition is 0 risk. The worst thing that happens is you eat donuts and drink juice and hang out with your friends and do some math for the morning. That's like the worst thing that could happen. The best thing that could happen, you also end up with a giant Hershey's candy bar, and we bring home the golden calculator and the pride of all of our mathematical ancestors that came before us as they shine down and smile upon our equations and solutions. So, well, our mathematical ancestors, or to be an angel, I don't know. So, all of that fancy me trying to wordsmith things. At extensions, today and Thursday, I'm gonna have math counts where we practice some of those solving skills. And actually, we're probably gonna run a couple mock team rounds because all of you can sit and solve problems. But the team round and splitting up a problem set and then coming back together to like check some things, that's a skill that some of us aren't as strong on. Excuse me, this Saturday's here in our library, we have the home turf advantage. Please think about coming. I'm going to be sending an email out to parents so all the parents know that it's happening. It doesn't cost you anything. And we're giving you donuts and juice. Right? Can't find it. Sorry, well, you're being selfish. Avi. It's morning. So I have these, I'm going to hand these out today at Math Counts. These are info sheets about it. 8:45 is arrival. So not too early. Yeah, arrive at 8:45. We get going at about 9 o'clock. Hazel? We can try to get some. I don't know if I'm getting donuts or who's getting donuts, but we also have fruit, like different stuff, like cut up fruit and I know. I'm trying to think of what else we have. I'm just giving options. All because she doesn't like fruit doesn't mean I can't talk about it. What else did we have in previous years? Granola bars, like breakfast bars. Bacon, I wish. Just like a skillet full of bacon. You know how expensive bacon is. Alright guys, it is time to switch classes, so head on out of here.